I'm Debbie Wagner, Regional Mathematics Content Specialist with the Kentucky Department of Education. In addition to the grade level content in the Kentucky Core Academic Standards, there are 8 standards for mathematical practices that teachers must intentionally implement from kindergarten all the way through 12th grade. The purpose of this podcast is to help teachers better understand ways to effectively implement the first standard for mathematical practice, which is to make sense of problems and persevere in solving them within a high school mathematics class. Karen Grace is a high school mathematics teacher at West Jessamine High School in Nicholasville and a teacher leader in the Central Kentucky Educational Cooperative Math Network. She encourages her students to justify their thinking and persevere when trying different problem-solving strategies in her classroom. Today, her students are making sense of problems by making connections between different features of polynomials, such as their roots, and how transformations of the functions affect the graphs. She asks her students to work in small groups to determine which algebraic representations match graphs of the polynomial functions.
Okay, so what are some points?
3.
3-0.
Okay, 3, 0.
0, -6.
Is that all you used?
Yeah.
Do we need any more?
No.
Why not?
Because it's diagonal connects.
Line.
Okay, we know it's a line. Good. We know this is a straight line, so we really don't need many more than 2 points. So if we graph this, this is what I saw on everybody's graph. Okay. Where's the x-intercept? On the x line, the x, what do we call this? X-axis, good. So Zax and Austin says what? What's this one? 3, 0. What's the other one? And 0, -6. I want you to take a minute. These are our zeros, or our x-intercepts. Talk with your partner about how does this relate to the equation. How would you graph that? Would you graph it and find the x and y intercepts? Huh? Well, others of us do too, but the fact of the matter is we're here and we're doing this. How do our intercepts relate to the equation?
Okay, I got it. His is probably wrong.
Well, what is it?
No, not yours.
All right, and let me get theirs.
Well, you see, 3 is on one side and 4 is on the other. You know, like they match. Yeah.
I see -4 and +4. Is it a complete match?
No, it's not. It switches. So.
Well, okay. What about graph C?
I said -14.
All right, so Maddie says, this is Maddie, x what? -14 and x + 5. Do you agree? Chris says no. Why not? What'd you get?
I get x + 4, 2 -7.
Chris says x + 4 and what? Huh. What's different about this? Why would he flip that? The graph is flipped. What do we usually do if the graph is flipped? Switch what sign? What do we? What becomes negative?
Positive.
Where do we put the negative usually?
Before the parentheses.
Good, Maddie. So we need a negative there because that's flipped. I would agree with this. Flipping this essentially is doing putting that negative out front. That's kind of what that's doing. That's good. What's this one going to do? Like this? A lot?
3 times.
3 times it's going to what? Intersect the x-axis. Very good. Okay. First of all, if you match two cards on your purple sheet, you need to explain why you matched them. If you match it, you tell it on your paper to tell why you came to your decision. You need to agree on your matchings. Okay? No, as a partner. I'm going to give you each a set of cards today. So you have to match them and your partner has to match them. You may find, listen, this is important, you may find that more than one function goes with the graph. And on some of them, if you have some left over, you draw the graph. Okay? The other thing is put your calculators off the table. So move your Nope, you won't need your calculators.
That's flipped, so that.
Did you all write down why you were
But it's touching.
Yeah.
so we can check you off? So we can check
I'm gonna be
you
going
off.
up 3.
I guess this is flipped. Just positive.
Yeah.
Negative. Well,
See,
it would
if
be
you start
going.
to see, flip it on that side to be like one of these ones up here, and just flip it, and it'd be positive 3.
No, they're looking at X. That would be Y. Well, no.
Robin, you and
Yeah.
Lucy played.
See what I'm getting at?
Yeah. X plus 3. But that. No, that only crosses once. I don't think that's right though, because
Touches.
if it was
Touches.
yeah, it only says it touches once. If there was, it would have to have another one to go in, because
Yeah.
that one's touching, so it's not this one. It's flipped, so that's negative,
Why did you match?
and it's not touching, so that's we have to draw this
Graph
one.
A with equation 2.
Or I'm gonna get a pencil. I don't want to color with the green.
There has to be.
The negative flips the whole thing from being positive, so it's
They all go to
automatically.
negative side, so this graph it's all negatives,
What
and
was your reasoning for
negative
matching those
plus
up?
1,
That's all you have
you
to
change
do.
it over here
You
to
have
negative
solve
1,
everything, just
and
write
it
the
touches right there.
reasoning why.
Then plus 2, we change it to negative 2, it touches over here, and then negative 4, it's last here, so that's the whole graph.
The 3 points intersects, or it intersects 3 times on the x-axis. Hold on. It would be graph B.
So those look a lot alike.
Yeah, it'd be graph A because it intersects 3 times on the graph on the x-axis in the negatives because it changes the positives to negatives. That way it's equal to the graph.
So is that the only one that intersects 3 times?
Um,
And over on the negatives?
check. It's not the only one, but it's the one that's closest that
So
fits.
what about graph E there? How is it different than graph A?
It hits the higher numbers, and this hits more on the lower numbers of the negative numbers on the x-axis. Like this one hits -4, and this one reaches up to like negative like 15 or something. But this one is closer to 0 on the graph than.
So what's the equation for E then?
The equation for E would be. Well, it'd also be x plus 1, x plus 2, x plus 4.
What's the difference in those two equations?
Oh, negative. Negative x plus 1, x plus 2, x plus 4.
So how do you know for sure which one matches which graph?
You're doing good.
I don't know how to explain it. since this is going down, it means that it's a negative, and since this one's generally going up, it's positive.
Okay, so what do you mean it's generally going down?
Like how the graph is like it's slowly like moving downwards, and this one's like slowly moving upwards.
Okay, so what do you do when you're trying to solve a problem and you get stuck?
Look at other problems that I've done previously and try to do the same steps I did up there.
If the teacher can help me, I'll probably just try to guess it out and use something that's logical, try to help me out. If I can't, then I just don't do the problem, skip it.
So you don't just quit?
Usually I don't. I mean, if the teacher can help me, I'll have her help me, but if I can't, then I'll just work my way through it and try and find something that makes sense.
All right, this problem solving with perseverance, having the kids engaged in activities where they have to do problem solving and they have to not give up. Does having activities like that in your class make your job easier or more difficult?
It's really just different. It's really easy to just throw a worksheet at a class and come up with a worksheet to throw at them. So that part of it, the planning, the preparing, is a lot harder because you really have to think about your task that you're giving. Where are students? What questions do you want to ask? The grading end of it sometimes ends up being a little easier because you can look at them as a whole class group and kind of sort and give feedback based on how different groups have done versus having to give individual feedback on every single paper that you have.
Poya is considered the father of problem solving, and he has that 4-step problem solving process: understand the problem, devise a plan, carry out the plan, and look back. How do you use this problem solving process or something similar to help your kids in your class do problem solving?
Students have to read and think through the problem on their own first, so they're kind of devising a plan, and then they give their ideas, and that's when we put them on the board, and from that we devise a plan. So when we're putting things on the board, I try to make sure that we put students' names with it so that they are owning each other's ideas. We can refer that back to that and saying, think back to John's idea or Susie's idea. And a lot of times they go back and they work, and if a student gets stuck, I can refer them to the board and there's a starting point for them. So that's there for them to go to as a reference. And it helps them carry out the plan. And then together we look back, I bring them up, I put the solutions under the document camera, allow students to look at each other's work and reflect on that. And a lot of times we'll do some revisions there too.
So what advice do you have for other teachers or schools who are transitioning into implementing not only the new content standards but also the practice standards, which do include the problem solving?
Don't expect change to happen fast. This has been a really slow process for us, but because it's been slow, it's been really good. We've worked on creating that climate, and slowly our students are learning that it doesn't matter which classroom they go in, these are going to be the expectations. You won't be able to get up and give notes and just practice problems every day. You're really going to have to sit down with another teacher and think through the tasks, think through what students are answering and give them feedback and develop your next steps based on that. Because when you just are up there giving notes and practice problems, the students aren't learning to think for themselves. They've learned how to play school. And even our best students, our accelerated honors students, have learned to play school really well and not necessarily problem solve. And when we take a step back and create that climate of problem solving and take away the things that they are used to, where somebody gives up and tells them how to do a problem first, we found that that's when the students really get into the problem solving.